Okay, so now we are going to be looking a little bit into what YAML files are. You heard already a lot about them, and it's basically the way that we chose to store the information about the models. But before getting into the details of what YAML files are, I'm just going to move this thing away. And I'm also going to be talking a little bit about the design of ESM-Tools. So how did we choose to design ESM-Tools? Well, we decided to have all the functionality part written in Python, but this part knows nothing about the models. It's completely independent of the models. This handles calendar operations, this handles the copying of the files, this handles the submission to the different like Slurm job schedulers. And so, but this knows nothing about the models. So we wanted to keep the Python part as detached as possible from the models. And so that's one part. And then another part of ESM-Tools is basically configuration files. And configuration files are all these three YAML files here that contain information about machines first. We have also information about components. When we talk here about components, we are talking about standalone models such as PESOM, ECAM, or OpenIFS, and also the couplers, for example, the Oasis 3. And then we also have setup files. Setup files are couple model setup files. So basically, they specify how to actually run couple models. So this is a very modular structure of storing information. So in a way, what we want to do is to have all the information specific to machines right here, all the component information on the other file, and most importantly, there is a hierarchy on this information. So you can actually have repeated variables in the machine files that are repeated in the component file. If all these are going to be used in your building or your running of the model, the question here is, they have the same name, how is this going to be resolved? And this conflict is resolved because there is a hierarchy, and that means that basically the component is above on the hierarchy, so that means that the variable on the component is going to win over the variable in the machine. And this is a very nice way of organizing information. So just to give you a practical example, and a very good way to actually get people to work on different models, but then use others people work into your workflow. So just to give you an example, Jan and I work quite intensively on getting ABCM3 running into Mistral, Jules, and Oli. And then Sveta wanted to run ABCM3 in an HLRN, in the HLRN computer. And we have never done this setup for HLRN computer, but we have some colleagues at Geomar that they have run FOSSI, which is a couple setup that has OpenIFS. And they have run it and prepared it on on HLRN. So basically, the biggest piece of configuring for ABCM3, in my opinion, is actually OpenIFS. And they have done the work for us. And because all was contained on this component YAML file, how to configure this for that particular computer, it was very straightforward to actually implement ABCM3 in HLRN. So ABCM3 sits here, and we have almost all the modifications we need for the complicated component already done by someone else. And that's the thing you can, and it basically going to help you to share your work, to share your own configurations with other people that maybe want to use your model in a different computer. So if they are going to use a model in a different computer that was never used, that means they are going to be using these two files, but they are going to have to create this one file and maybe do some adaptations here. But most of the work is being done already. So we've been talking about the configuration files. We will define them in detail later on. But then we also have our run script. And for the moment, the only thing that you need to know is the way that is your way of interfacing with ESM-Tools. And basically, whatever you write in your run script that is repeated across the files below, your run script is going to win, because we want to give you full control of what you are doing and how you're running your simulation. So these configuration files here. They are defaults, but you can override them with whatever you put in your run script. Okay, what you can see that all these files have in common is that they are all YAML files. And that brings us to the next step, which was to define what the YAML file is. So it's actually, YAML files are actually a way of storing data, and you can see some equivalents to these YAML files. For example, they are quite used across especially on Python. You have XML and JSON. And you can see that the syntax of these great data files, it's a bit more complicated and a bit more tedious to write. However, on the YAML files, it's very Pythonic in a sense, because you are using just spaces to nest information inside other keys, and basically you have also lists, variables, and it's all, you don't need any curly braces or brackets or anything. Okay, so we are not going to focus much on the right pane, but we are going to focus on the left pane, which is the right pane is basically Python script. On the left pane we have actually a YAML file, and what you can see here is that we have a variable h, which is an integer, 18, so it has support for integers. We also have a variable here that is a string. We have a variable that is a date. And this is, dates are not supported by YAML. I think they are taken as strings, but we support them on ESM. We recognize them on ESM-Tools through our syntax. Another thing you can see is that you have lists. We will define what a list is, but probably you know already. And we also have dictionaries. In fact, the whole thing, when you load this whole thing into Python, it's already loaded as a whole dictionary. And that's basically what we are doing here on the right. We are importing the YAML dictionary, the YAML module that allows you to load a YAML file and parse it. And then we are doing here different operations and extracting different stuff from this data.
So you can actually copy and paste that file, and if you also have the YAML module available, then you can run the whole thing and you can play with it to see how it works.
Yeah. But anyway, we are not going to be touching today onto Python code, so because that's more of an ESM-Tools internal. Yeah. Yeah. So basically, what ESM-Tools is doing, I don't know if you remember, but we have the ESM parser module. What ESM-Tools is doing every time you run either ESM master or ESM run scripts is taking all the configuration files that are needed for this particular operation. It's parsing it, and then it's understanding what you want to do with it, and then it's running this. Then it's running basically this command. So we say that YAMLs are basically a way of storing data. They are files that can contain lists, lists, dictionaries, and variables. But that's not enough for interacting with ESM-Tools. We have a layer of functionality, and we need to be able to trigger this layer of functionality. And for that, we have a series of feature variables or extensions to the YAML syntax. And that's basically what this workshop is about. It's about learning this syntax. So we have, for instance, something that is an extension of the YAML file. If you put the $sign and curly braces, you can call a variable, or you can link a variable that is somewhere in your data already. And you can use it to operate. You can run math and calendar operations using this dollar and double parentheses. You can extend lists by using add, or you can also extend dictionaries. We are going to be looking at all of these. We also have a feature, for example, we mentioned it already earlier, for changing name lists from the YAML file. So this is name list changes. And then we have choose blocks here that are basically switches in what you will know as a switch on a regular programming language. And again, there is one chapter for each of these and many more actually.